Okay, so let's get started. Today we talk about optimizing your SQL queries. And we have three topics on the agenda. First one, before you even start to dig into what query is your slowest query, how to fix it, what indices to add to a tune table, and so on, there are some things you need to do. You need to do some sanity check for your system. Right? After that, we'll dig into the what query is slowest, what can you do with this query, and so on. So for sanity check, recognize this character. Come on, IT crowd. It's a British sitcom about a support department of a large corporation, and the pinch line for that character is, instead of hello support, he's hello, have you tried to turn it off and on again? We wouldn't ask you to turn off and on your production server, but we will ask you to do some very necessary things to make sure your system is in kind of sane state before we dig into performance of particular SQL queries. We will ask you, have you tried tune table? If you haven't tried tune table, we wouldn't talk to you until you do. We'll check status of your global buffers, right? And we'll wonder why you are not on the latest version. So let's dig into those. Tune table, the most important factor of SQL performance. Without tune table, your optimizer is totally blind. It would literally pick the random index if you have multiple conditions or join. So what tune table does? Tune table samples your tables, your fields, and collects three, but two most important values. For every table, it would collect extent size, how many rows you have in this table. In the latest, relatively late new versions, it would also collect block count for a particular index or particular table. It would collect selectivity, how unique are values within your table. Let's say for gender, selectivity would be 50%, right? If you have some unique fields such as social security number, we'd just assign it 1, which is, I mean, that's the best index to use if you have conditions on that field. Right, there are some challenges with tune table. For instance, you might have sample database or customer database on which you can run tune table and gather statistics, but the system you ship to your customers have no data, maybe a couple of reference tables such as state name abbreviations filled in, but no transactions, no orders, nothing. And there's a way to deal with that. If you have the system on which you can run tune table and collect statistics, then you can export these statistics and import that in a brand new database. So even for your customers who have no data in their database, they already have these pre-populated values in their system. So let's give it a try. Let's run a query without tune table and then run the same query after we run tune table. Go. Screen resolution is not perfect, but bear with me. Let's switch. Show incorrect namespace. Just query and execute. So something happened, but we have a matrix that we can use to identify how efficient our query is. So if you run in with the sample database, this database barely have a couple of thousand records in there. What you're looking for is the metric of global references and lines executed, right? Time is subject to a whole bunch of factors. Maybe you have some other processes running on your system. It might or might not, data might or might not be on disk. Global references and lines executed would be consistent on the same set of data. And even on very small sample data set, it still would be representative, right? Oh, we can check the plan for this query. And plan basically says call module B, and in module B, the first thing we look at is a bitmap index on product. So we have index at least on one side of the join, and we're using that because that's the only decision we can make based on what we know about the tables. Now, let's go to the, and again, the query itself is basically a join between product and transaction table. Right? So let's go there, to action, tune table. So right now, to the tune table statistic, tune table was never run on this system. So extent size that we have there is 100,000. So by default, optimizer assumes that you have 100,000 records in every single table. Obviously, that's not the case. So let's run tune table. And in fact, we have just 17 records in this table. All right, let's do the same with transaction. Again, 100,000 by default, but in fact, it's barely more than 2,000. So, tune table is run. Let's go back to our query and execute it again. So, anybody memorize the number of global references and routine lines? Right. We have about order of magnitude drop in both. If we look at the query plan now, right, again, we call module B, and now we're looking on master map on the product table. Usually, if you see reading the master map, we're talking about full table scan, and that's bad, but not for the table of 17 rows. Right? So basically, we have an index on one side, but that's an index on the side of the huge table, right? And it makes way more sense to run the same, do the same join starting with the smaller table, right? That's why we need extent size. Mostly for join selectivity, we need for figuring out what index within particular table to run. So, tune table is something you absolutely have to do. The second thing, and I'm personally always surprised that people keep their global buffers into their default value. The default value for global buffers, depending on the version, but more or less something around 256 megabytes. So you have 16 gigabyte of memory on your server, and you're using just quarter gigabyte for global buffers. No wonder your system is slow. Right? So, absolutely essential. And like, I'm speaking from my experience, I've seen system in production with hundreds of users with global buffers left to default value. Right? There's whole science behind how exactly you identify the proper value for global buffers. But at least make sure you know you should not leave it in default value, right? It should not be an automatic in management portal. If you're looking at your configuration file, if you see all the zeros against the globals parameter, that means you leave it in default, which is no. Okay, just move. Okay, there's way more to the system configuration. There is a very interesting things about your storage configuration and, for instance, how do you manage swap file behavior on Unix and Windows. It's outside of scope of what we're doing here today, but the message here is make sure your system is configured properly. Right? Global buffers is like the first thing you should do, and then comes a whole bunch of other things on the OS level, storage level, and so on and so forth. There's a very good opportunity right now at Global Summit to talk to our technical architects team led by Mark Belinsky. Right? There are a bunch of sessions, some of them running next door about system configuration. Right? There is WRC, our support. They do have dedicated system performance team that would help you with configuring your system, allocating new buffers, and so on. And finally, we would encourage you to upgrade to latest and greatest version. Just by upgrading, without changing single line of code of your application, single SQL query, you most likely would reap the benefits of all the changes we're doing in the system. SQL parallelization, on the very low level, we doing a lot of work to make sure you can utilize all the cores in your system. We switch into async input-output on the platforms where we can do that, and so on and so forth. At the same time, we do understand upgrade, especially in large enterprise on production system. It's a challenging task. You have to test, you have to get some downtime for that, and so on. But again, if you can, please do. Just a few examples of benefits from the SQL perspective that you get by upgrading to recent versions of Cache. Change with codename DPV4562. Right? It changes the way we generate the code of cached queries. If prior to that change for storing some temporary variable, we would use single integer subscript arrays. Now we use just local variables that has last few digits as numbers, right? Fairly simple change for us, but all the tests we've run showed at least 14 to 48% improvements in execution speed, right? That's kind of idealistic scenario, all the data is cached, but the point is there is no way this change would harm performance of your system. Like, if anything would happen, this change would be beneficial for you. As we don't change execution plan, we just change the way we generate the code for this plan to execute. Well, again, this idealistic situation, all data in memory, so on, like you might have queries that challenge not by execution speed itself, but by need of reading data from disk and so on. But again, there's totally no harm in this change. There are a couple of other examples. Recently, we started to, if we see OR condition in your query, we would change it to union all underneath and execute the plan for union all, and that gives us usually a lot of benefits in terms of execution speed. We can generate more optimal plan, we can use parallelization, and so on. But there are 4 documented exceptions that we have. Like, out of all thousands and thousands of customers, we have 4 customers who legitimately complained that that particular change caused negative effect to the performance of their queries. It's very easy to fix. All you need to do is just the SQL hint we introduced, but just to make a point, right? If we make any changes in the query plan, it might happen that you're among this very tiny percentage of exceptions. Same for outlier selectivity, right? Let's talk about outlier selectivity a little bit for a moment. Without outlier selectivity, to calculate the selectivity, we just collect the number of distinct values, right? And if number of distinct values is 3, we would say selectivity for this particular field is 33%. let's take a look at our support. And again, obviously 33% is not that good selectivity, so index on that field would not be preferred index, right? But there are many cases where you have one value that totally dominates your table. Like for our support system, we have 3 statuses of the problem: open, closed, and pending. Obviously, vast majority of the problems would be in the closed state, right? So what we're doing right now, we're calculating selectivity as part of outlier selectivity as part of tune table, and we assume that you don't want to query on this outlier. You rarely would query on closed problems. What you're interested in is problems that are either open or pending, right? So therefore, selectivity value for that particular field would be totally different than just number of distinct value divided, 100% divided by number of distinct value, right? And that works just fine for most of the customers, but sometimes things happen and people do query this outlier value. So a couple of things you can do here. There's a special construct, this double parenthesis, that says, hey, I do know this is outlier value, so optimizer, please do your homework and create a different plan if you see fit, right? If we indicate in our query statement that that's an outlier value, optimizer would most likely ignore the index for that field because it knows it would select pretty much every single record. Right? But again, if you just upgrade to the version that introduced this and you still query these outlier values, there's very slight chances that you would be in minority of customers that see the negative effect from this optimization. Again, very easy to fix, either a SQL hint or these contrasts, but again, exceptions happen. So to deal with these exceptions, we introducing in 16.2 the new feature called frozen plan. So what frozen plan is? Frozen plan lets you literally capture the plan that you have on your current version, do upgrade, and no matter what optimizations we introduced in the newer version, keep running the old execution plan. So that brings you to 2 possible upgrade scenarios. One is pessimistic, like I don't want any changes. So you freeze all the plans, you upgrade, and then there's a special SQL hint. I didn't pick that name, by the way, for the record. And you test your queries with this hint and see if a new plan would be better or not. If it's better, you unfreeze the plan and new plan kicks in. If it's worse, you just keep it frozen. Right? Another option, you go in optimistic, you just do an upgrade, let all the queries to run on their new plans, and if you detect any particular query that look worse by any chance, you have an option to import the old plan from the backup and apply it to the newer version. And we have the whole dedicated session on this global summit right for this feature, painless SQL upgrade sessions. So let's find it. The best tool to identify the problematic queries in your system we have right now is %sys.PTools. Right. By the way, sometimes you don't even need to identify the query. You know this report runs for 20 minutes and you know what SQL query behind it, right? That's no-brainer. But sometimes you have little queries that an execution takes maybe 100 milliseconds, so you don't notice that, but you execute in that hundreds times a minute, right? But you don't know that. So PTools would attach itself to the very beginning and very end of your cached query or embedded query. And if you activate it, it would record statistics global references, routine command, time it took to execute into special system table. Right? So you would run it for a while, and then you'll be able to interrogate the system tables by querying this table. In, I think it's 2013.1, we introduced a user interface to that. I still found the querying the raw data being way more beneficial, uncovering way more problems, but you know, we have the user interface to that. So let's give it a try. So if we go to System, Tools, SQL Performance Tool, Runtime Statistics. Okay, let's switch to the right namespace. User, purge cached queries. So basically, we reset the statistics and run this loader again. So basically, that's a test script that executes few random queries. In this particular case, 10,000 times. So let's take a look what we have in the stats. And we have 5 different queries. We have the average number of command lines, I/O wait, average time, number of times this query was executed. So even though average number of global references and commands is more or less the same, we know we execute this particular query more than any other query. Right? And we can show a plan for this query and so on. Again, way more information you can get if you'll query this system table, system views directly. So let's do that. So that's kind of for raw data. Right, it gives you one record per every execution event. If you want, like, this is what I usually use. So I'm aggregating values in this table, and as you see, the very last line there, it has the biggest total execution time. Right? So if I am to optimize any of these queries, I'll probably start with the last one. Right? So this is the way for you to identify what query puts the most load on your system. Right? Or you can go ahead and do like which one takes the maximum possible time to execute, and so on. But you know, it's a SQL, right? Do whatever you want with it, analyze it any way you want. Okay. And that's the query we just run and the example output on there. Right? That's the best and easiest way right now for you to identify the slowest query. There's another tool we have called SQL Index Analyzer. It doesn't collect execution statistics, so it doesn't tell you which query is run the most, but it would scan all the inventory of all your cached queries, inventory of all your embedded SQL class queries, and so on, and would gather statistics based on the query execution plan. The statistics it would highlight is, are you doing any full table scans? Right? Full table scan is not good except for these very tiny tables. Do you have joins that don't have indices on either side? Right? Do you build temp indices? That's again indication that your query is not optimal. And last but not least, do you have index that was never used? Maybe you should just get rid of a bunch of indices so your data modification operations would run faster. Yeah, another thing we just introduced in 16.2 is, along with global references and lines executed, we now show you what disk latency is. So basically, while you're executing the query, do you read data from disk or not? Right, so try to run the same query 2 times. Right, if both times you see disk latency non-zero, that means you're probably short on global buffer, so your table is humongous and would not fit in global buffers. If on the second time your disk latency is 0, but it's still slow, you should consider adding an index or somehow optimize your queries. So again, in 2016.2, we introduced statement index. And statement index in 2016.2 is the place where you store this frozen plan. In 2016.4, we introduce lightweight, always-on SQL monitoring in your statement index. So statement index keeps inventory of all the queries you ever run. And starting 16.4, it would collect similar statistics to what PTools connect. So why PTools is not good enough? PTools is a perfect tool, but you don't want to leave it on all the time. Because for every statement that's being executed by your application, you add in the record to the system table, right? And that consumes both CPU cycles and disk space, right? So that's kind of invasive tool. What we're doing within statement index is totally non-invasive, right? We would collect data about execution time, global references, and so on, but we'll keep it in memory for relatively long time. Then we'll update, and we'll update only aggregates. We wouldn't do the wouldn't recalculate the whole thing, wouldn't add new record there, right? So very lightweight. We test a lot from performance standpoint. We don't see the noticeable effect. There are some exceptions. There are something what we call natural queries. And natural queries, it's queries that uber fast, right? You do in select of single record based on unique index. Like you expect to do 1, at most 2 global references to get this data. Maybe you would have some overhead if you start counting statistics for this. So we don't count statistics for these natural queries. Anything that would give you more than 2, 3 global references at most, we would collect these statistics. Like with PTools, we have GUI user interface as part of management portal, and all the data, all the raw data accessible to you from this information schema statements table. Right? Once again, it's you can't try that yet. That's part of 2016.2. There's a chance it would be renumbered as 2017, but this thing is coming. This is inevitable. So finally, let's fix it. Assuming you tried everything, you run tune table, your global buffers are in a good shape, and you on the reasonably recent version, right? The next step would be to identify the slow query. Yes, we identified the slow query already using PTools or statement index. Next step is to analyze query execution plan. So, analyzing query execution plan is sophisticated exercise, let's put it this way. There are a whole bunch of things like modules, calls, temp files, temp indices, and so on, but the basics are fairly straightforward. The basics are every table stores data in indices in maps. Master map is your table itself, your D global, right? If you see this master index being used as first index within your query, you're doing full table scan, most likely that's a bad thing, right? But if we know that table is super small like that product table, maybe not, right? Other tables, other maps are index maps. You can have your B-tree map, bitmap, bit-slice, and so on. So basic analysis for the query is you have to be able to navigate the execution plan. Like, and it's fairly simple. Like we say call module B, right? And module B reads the map. What map is that? So that's the index or master map you start your execution from. That gives you an idea what index is used first, like how optimal is your plan. So let's do that. We have our query. Need to execute that in samples namespace. Again, just note the number of global references and routine lines. Show plan. And what we're doing here is we call in module B, and module B reads master map on sales transactions. Sales transaction is a big table, so we're probably missing an index here, right? By the way, not that many people know that. If you go in through PTools and exercise, you identify your query, you'll identify it like this, right? With question mark instead of parameters. To execute the query, you need to replace this parameter with actual value, number in this particular case. To show plan, you don't need that. To show plan, you can leave this question mark. So as soon as you identify the query, you can at least look at the query plan, right? And then you can task yourself with figuring out the right parameters to pass so you can actually execute that, right? So we can guess that we're missing an index here, an index on discount in this place because it's the only field in where condition. Let's add this index. And execute the same query again. So you see the difference in number of global references and routine lines? Yeah. Again, these are your two best metrics because time, you know, depending on how big your database and what's going on in your system would fluctuate. Global references, routine commands would be more or less consistent across the board. And if we look at the plan now, right, same thing, call the module B, but in this case, module B loops through, try this. Loops through index, right? So again, the one essential skill that you can easily master analyzing the query plan is to find in the first map that's being used. If that's master map, you're doing full table scan. If it's index, you're using that index, right? You might think and argue if that's the right index to use or not, but at least you do know what your query is doing, at least at first glance. So again, that's essentially what we did. The query here is a little bit different. I'm not doing group by, so number of lines is a bit off from what you've seen in the management portal, but again, same idea. Sometimes you don't even have to go into query plan analysis. Like if you have simple conditions, like at least one of these two fields should be indexed, right? And more likely you would put index on field 1, because it probably would have more distant values, but we don't know, at least in this particular case, what field 1 is. The second is, if you're doing a join, you should have index on either one or two sides of the join, depending on the join type. Right? Again, you don't need to analyze the query execution path to say that you need that. Another thing you can do with the query itself is take advantage of new parallel execution. Right? There's a Flash token developer zone about parallel SQL. I'm talking about parallel SQL in my distributed SQL session. Introduced it in 2013 for unions only. In 15.2, we enhance it so we can slice the table by the range, by the ID range, and multiple processes can do that. Good for aggregates, group by, and so on. So just give it a try. All you need to do is after your from clause, add %parallel, right, and see what the difference would be in execution time. Yeah, another thing, and just to illustrate the concept of SQL hints, we have %ignore index as a statement that you can use to make sure that index that you don't think need to be used would not be used. Similar to outlier selectivity, again, for intersystems, the most employees would have their home state as Massachusetts, right? So likely you would not want to use that particular index if you're querying for Massachusetts. Then you can use this double bracket syntax. So optimizer would generate special plan just for that particular value, right? Otherwise, it would generate plan for question mark. Right? But it's still dependent on statistics, what outlier value and outlier selectivity you have in your tune table stats. It still might use index on state. To make sure index on state totally ignored, use %no index hint. Just before every where condition where you want to make sure index is not used, put %no index. There are multiple of hints like this, and I would refer you to our documentation, right? Some of the hints would solve this problem of union or optimization, right? Just don't do these optimizations. That's literally what this SQL hint says, right? And a lot of those in our SQL engine. So that's pretty much it. A couple of words on what you can do from here. We do have 2 gurus on SQL Performance from our support group right here in Developer Zone, Kyle Baxter and Brandon Bannon. They're very nice folks to talk to if you have SQL problem. Feel free to use to myself or Tom Woodfin, who leads our SQL developments now. There's some materials in our learning group, including this one. That's probably the best primer on SQL Performance, even though it's a bit outdated right now. Right? In 16.4, so it's not available to you yet unless you ask, there's a very good book as part of our documentation, which is Optimizing SQL Performance. Right? 16.4. It's in 16? Oh, good. I thought it was 16.4. And for sure, reach to your sales team, to your sales engineers for additional engagement. Like, we'll be happy to help you to analyze this, analyze your queries, give you suggestions on what you can do. But we will always ask our conversation with, have you tried to run tune table? Yeah, and we have about 5 minutes for questions, and I'm gladly answer them.
When you're setting up indexes, are there any general rules as far as individual single property indexes or creating combined property indexes?
One general rule, never do combined indices as bitmaps. The beauty of bitmap indices is if you have index on field A and field B, and they both bitmap, unlike B-tree index, bitmap index can be overlaid, right? So never do bitmap indices on multiple fields. For B-tree indices or regular indices, you would use one index. You can't overlay those indices. So if you have a particular query that you want to optimize to extreme, it might be a good idea to have index on multiple fields, and maybe even a better idea to add data to that index so you don't have to touch the master map to get the data that you need. So your query can be satisfied entirely from index.
Now, you were talking about running tune table earlier. I'd like to know what type of performance cost. We've got some tables that have got 150 million records. They're very busy. We're running Ensemble in a healthcare application. So what are some of the things that we need to be wary of if we're going to run tune tables, say on nslib HL7 message?
I cannot speak to system tables that Ensemble maintain. I just don't know what kind of rules of engagement there. If you have your own application tables, and these tables are huge, unless you're on a very, very old version like Cache 5, which you're obviously not. 2015 one. Well, excellent. So tune table would not scan every single record, it would do sampling. So statistically significant sampling of your database. So there is some performance impact, but it's not nearly as huge as you might imagine if we'll count every single record in every single table. You might consider, if you worry about performance again, you likely have backup of your production database. Run tune table there, export statistics, and apply that to your production, if that's your significant concern. Anyone else?
All right. In your SQL query, can you specify the index that you want to use to cache instead of cache trying to work it out automatically on its own?
I'm not sure I got it, sorry.
Can you specify the index that you want to use in your SQL query?
Can you specify index that you want to use? No. You can specify the index you do not want to use, which is no index hint. Anyone? Okay, then thank you very much. You know what people to look for in Developer Zone, or try to find me. And have the great rest of your conference.